by sandwiching a P-type material and an N-type material. Reverse biased, we are changing the polarity. Then what is forward bias and what is reverse bias? Recombination of holes and electrons is not possible. Now, how will I break that potential barrier? Increase the external potential or voltage. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Continuing our discussion on semiconductors, my today's session will aim describing biasing of semiconductors. The two important concept called forward biasing of semiconductors and reverse biasing of semiconductors. Before that, we shall recall a few concepts which we did in yesterday's session, where we understood about an intrinsic semiconductor and extrinsic semiconductor. We told intrinsic semiconductors are chemically pure semiconductors. Their conductivity is very, very less. That is why we add impurities. We dope intrinsic semiconductors and the impurities added are called dopants. And an extrinsic semiconductor is a result of doping an intrinsic semiconductor. We studied the two classifications, the two types of extrinsic semiconductors. One we call P-type and the other we called N-type, and in detail we studied the differences between P-type and N-type semiconductors. Now, going forward, in today's class, we will study what is meant by biasing a semiconductor. And through that, we will understand what is forward bias and what is reverse biased. So before understanding what is forward biasing, what is reverse biasing, we will understand what is meant by biasing a semiconductor. Now, a diode, a semiconductor diode, which is the result of a p-n junction. So, if you observe, a diode is said to be biased when an external potential difference is applied across it. Andre, suppose I have a PN junction diode. PN junction diode, which is formed by using a P-type material and an N-type material. And this is called the depletion region, where the charge carriers are not allowed to enter. Forbidden region, depletion region. Nenpitkoli, a PN junction diode is formed by sandwiching a P-type material and an N-type material. One the P-type semiconductor matte N-type semiconductor na sandwich madidre adana junction diode ant karitare. Ivugal madhya idana depletion region ant heltive, where either the holes or the electrons, generally what I call as charge carriers, cannot enter. Now, suppose this diode, the so-called junction diode, is connected to an external source, a battery, such that a potential is applied across it. Some external potential is applied across the diode. Then we say the diode is biased. So, students, what is meant by biasing the diode? It is applying some external potential to the diode. How do I connect, or how do I apply that external potential? I will connect the PN junction to an external source, a battery, so that I can apply some potential. Now, there are two types of biasing. One, as we mentioned, as forward bias, and the second one, what is mentioned as reverse biased. ತಿಳಿದಿಟ್ಕೋಬೇಕಿದನ್ನ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಗಳು ಮಾಡಿ ಡಿವೈಸ್ಗಳನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದಿಕ್ಕೆ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ and concept of reverse bias. The first diagram indicates the concept of forward biasing the diode, and the second diagram indicates the concept of reverse biasing the diode. Hagandre, then what is forward bias and what is reverse bias? If you observe, so this is the symbol of the diode. A junction diode is always represented by this symbol. Base of the diode is the P-type material. This is called the nose of the diode, which is N-type material. Now, if the P-type material is connected to the positive of the battery and the N-type is connected to the negative of the battery, then we say it is forward bias. Meaning to say what? P-type majority charge carriers are holes which is positively charged. N-type majority charge carriers are electrons which is negatively charged. Andre, I'm connecting the positive part of the diode to the positive of the battery and negative part of the diode to the negative of the battery. So positive is connected to positive, negative is connected to negative, and this is called the forward bias condition. Therefore, we say a diode is said to be forward biased. Forward biasing andre, if the P side is connected to the positive terminal and N side is connected to the negative terminal of the battery. So very beautiful. P has majority charge carriers holes which are positively charged. So I am connecting it to the positive of the battery. N majority charge carriers are electrons negatively charged connected to the negative of the battery, which means the positive of the diode is connected to the positive of the battery. Negative of the diode is connected to negative of the battery. Under this condition, the semiconductor diode is forward biased. On the other case, now if you observe here, the P-type material is connected to the negative of the battery. N-type material is connected to the positive of the battery. Andre, P-type material holes positively charged, N-type material electrons negatively charged. So positive of the diode is connected to the negative of the battery. Polarity change agide. Negative of the diode is connected to positive of the battery. And under this condition, we say that the diode is reverse biased. And therefore, when we understand reverse biasing of a semiconductor, the diode is said to be reverse biased when P side is connected to the negative terminal. P side holds majority charge carriers and N side is connected to the positive terminal of the battery. And this is what we call as biasing a semiconductor or diode. So biasing andrenu? It is very simple, meaning to understand. We are applying external potential difference across the diode. An external potential difference is applied across a diode using a battery. What is forward bias? P-type material where majority charge carriers are holes connected to positive of the battery. N-type material where majority charge carriers are electrons connected to negative of the battery. This is forward bias. Reverse bias, P-type material connected to negative of the battery and N-type material connected to positive of the battery. Now, this is exactly how a PN junction diode is seen. This is the P-type material where majority charge carriers are holes. N-type material where majority charge carriers are electrons. In between is the depletion region. Barrier. We say the depletion region is also called as potential barrier depletion. It is also called a potential barrier. P-type connected to the negative of the battery, N-type connected to the positive of the battery, and this is reverse bias condition. This is a graph, VI graph, voltage current graph, which exhibits the working of a diode under reverse bias condition. We have current in microamps and potential in volts. Now, what you have to understand here is when the diode is reverse biased, I am trying to understand the action of a PN junction when it is reverse biased. So when the diode is reverse biased, as usual, the holes are attracted by the negative terminal and electrons are attracted by the positive terminal of the battery. Reverse biased, we are changing the polarity. Holes connected to negative terminal, electrons connected to positive terminal. As a result, the width of the depletion region and potential barrier increases. Very important. So, as we have reverse biased, where holes connected to negative terminal, electrons connected to positive terminal, the width of this depletion region the so-called potential barrier goes on increasing. And that is, the diode does not allow current due to majority charge carriers. Andre, since the width of the depletion region is more, the barrier width is increasing. P ಮತ್ತೆ N junction ಮಧ್ಯ ಇರೋ ಗೋಡೆ ತುಂಬಾ ಜಾಸ್ತಿ ಆಗ್ತಿದೆ. Recombination of holes and electrons is not possible. So large current cannot be constituted. But there will be a small current due to the flow of minority charge carriers. And this small current is called reverse saturation current. Andre, because of that potential applied, there will be still a very small current flowing in the circuit. Microamps irutte. That is what the graph showed. Microampere, very small current, and that is called reverse saturation current. So in the reverse biased mode, where the hole is connected, the p-type material is connected to the negative of the battery, electron is connected to the positive of the battery, the width or the size of the depletion region, potential barrier, is maximum. Holes and electrons cannot recombine. You cannot get majority current there. But still, a small current due to the external potential or minority charge carriers, which we call reverse saturation current. Now, if we understand the VI characteristics of the PN junction in the reverse bias was shown in the graph. Now, the reverse biased resistance is given by, as usual, delta V by delta I. This is called reverse biased resistance. ಗಮನಿಸಿ ಇಲ್ಲಿ, resistance is V by I, but here in this case it is delta V by delta I, which is change in potential to the change in current. Small reverse saturation current. Therefore, it is delta V divided by delta I. Change in potential divided by change in current. And this is also called as dynamic resistance of the semiconductor. Dynamic resistance when the semiconductor is reverse biased. So, what is this breakdown voltage now? The reverse bias voltage, or which reverse bias current increases sharply. Breakdown voltage andre, if the reverse current has to increase, if the magnitude of the saturation current has to increase, I have to break that potential barrier, that depletion region. Only then the holes and electrons can combine. Only then I can get a sufficient magnitude current. Now, how will I break that potential barrier? Increase the external potential or voltage, and that is what is called breakdown voltage. And we spoke about reverse saturation current, a small current. Saturation, it is constant, and it is of the order 10 power minus 6 ampere. So in today's class, we have clearly understood what is biasing of a semiconductor, and when a semiconductor is said to be reverse biased or forward biased. We understood the action of a junction diode when it is reverse biased. And finally, the concepts of breakdown voltage, dynamic resistance, and reverse saturation current. In my next session, I will come up with rectification, beautiful topic, full wave rectifier, half wave rectifier. Until then, have a good time. Thank you.